Welcome, everyone, to the Metrics International Forum. The forum is organized by the Meta Research Innovation Center at Stanford, or Metrics for short. And the center is directed by John Ioannidis and Steve Goodman, and we are a research group and fellowship program dedicated to finding ways to improve the validity and transparency of scientific research. My name is Lina Koppel. I am a visiting postdoc at Metrics, and I will moderate the session today. All of the forums are recorded and can be accessed on our website. Please mute yourself during the talk and keep your questions until the end, or you can also write them in the chat during the talk. Our presenter today is Antonio García Romero. Antonio is a full-time professor at IE Business School in Spain. His research has explored a wide range of topics, from evaluating the influence of biomedical research on hospital performance to developing indicators for assessing healthcare innovation. Recently, he has also focused on the disruptive potential of generative AI in healthcare. He also has a background in health policy and has served as the head of research and innovation policy for the regional government of Madrid. And in terms of meta-science, he has conducted research on scientific misconduct and bibliometrics. So with that, I will hand it over to our speaker. Thank you so much for being here today.
Thank you, Lina. Thank you for your presentation. I'm very happy to be here and share with you the paper I'm going to present today. I have to say before I start that this paper started as a project working with students, undergraduate students, and I'm very proud of that because we have been able to produce a paper and submit it to a good journal. Currently, this paper is under review in Scientometrics. To start, I would like to state something that I suppose that everybody agree. Scientific misconduct is a very serious concern among scientific community, science policy, journals, etc. And probably generative AI tools will boost this problem because now almost everybody can produce a paper almost from scratch. And in this context, you know that flawed research may cause damage in several contexts, particularly in further research, but also in health and education. It is true. There's not a saying that research is conducted in business, where the effects are not so dramatic that in other areas like health research. And this is an example of a classical paper published in I think in the 60s, last century, that never was retracted, but it should have been retracted because it was a flawed study that focused the problem of coronary heart disease on fat rather than sugar. This paper has caused that millions of doctors worldwide have treated their patients wrongly. So the effect can be serious and beyond science. Fortunately, in business and the fields that we are going to consider in this paper, these effects are not so dramatic. But we have to keep in mind this example because then there could be other examples. So the problem is scientific misconduct, and the solution could be the retraction. So retractions is a mechanism that scientific community use for assured quality to avoid flawed research paper. Misconduct research will be used or after its publication. Retractions means that the journal retracts the paper, and the paper cannot be read anymore. But and the statistics support that the number of retractions has increased over time, as you can see in this chart. Surprisingly, in 2022, maybe the slope is significantly higher. So maybe this is the ChatGPT effect. I don't know. So the number of retractions is increasing, but this is not the solution. Apparently, this is not the solution because retracted papers still receive citations. And maybe we can think, okay, they are cited because readers are figuring out that this paper was fake or was flawed. So this is manipulation with data, whatever. But this is not exactly true. So what is going on is that most of the post-retraction citations are actually positive. You can see here. There are several pieces of evidence that support this result. So the situation is the number of retracted papers is increasing. They're still cited, and the citation seems to be positive. So I think that the situation is serious enough to study this topic. Okay. So the objectives of this study, we have two main objectives. First of all, we want to analyze the factors influencing total post-retraction citations, the number of total citations. But also, we found very interesting to break down the analysis by type of citations. And when I mean by type of citation, talking about if the citation is relevant for the study that cites this paper, or is just part of the background, the methodology, or the results. And we are able to measure this type of citation thanks to Semantic Scholar. Semantic Scholar uses AI algorithm that reads the paper and classify the citation into these four categories. It is very important to understand if the citations are within the category of highly influential, background, or methodological, because I think that we are shedding light to the problem. So when we review the literature about retraction and citations to retracted papers, we can point out four main ideas. The first idea is that the retractions don't stop citations. This is quite clear. Maybe citation decline, but never stop. So papers are continuously cited over time. And that put the mechanism that we use for keeping the scientific integrity into a serious problem, because the self-correction mechanism to preserve the scientific integrity clearly is not working. I mean, the retractions is not enough. We have to go further. A third main idea that we can collect by reviewing the literature is that the journal impact factor, the journal prestige, and also the author prominence, including the institution where they work, and for sure the field, influence the post-retraction citations. And the fourth idea, for me, is the most surprising. The most surprising is that most of these citations are supportive and they are not criticizing the paper at all, right? So based on this idea and the previous literature, we have posed three hypotheses. The first hypothesis is, as you can see in the slide, is how the journal prestige affects or cause an increase in the number of post-retraction citation. We have several pieces of evidence that support this idea. Some of them are empirical, another one are theoretical. But for example, Fang et al. And Furman, they have found that the journal impact factor influence the number of citations after the retraction. Makes sense because they have perceived more, the credibility of these sources is bigger, and also is the type of journal where the the most prominent researchers usually publish these papers. So it makes sense that these journals are more cited as a whole, and particularly with retracted papers. The second hypothesis is about the institutions or the prestige of the author, which is the prestige of the author is a variable that comprises many other variables, and one of them is the institution where they work. So some papers, some studies have found that there is a clear effect from the institutional prestige to the citation. So the papers published from the top universities in the world are more cited, even if they have been retracted. This also makes sense, this assumption. And this is what you can find in the literature. And the third hypothesis is regarding the severity, the misconduct severity. What is the effect causing post-retraction citations? In other words, are scientists aware that what is the misconduct, what is the infraction caused by done performed by the authors, or they are not aware what's going on with the paper? So when you look at the literature, there are some pieces of evidence that support the idea that the more severe misconduct cases receive fewer citations after they are retracted, because maybe they are very famous cases that has been known even in news and newspapers or social networks. X, for example, former Twitter, you can see some piece of news published about the retracted papers. It also has been observed that the reason for retraction has been can be one of the reasons the citation decline, but it's not so clear. Not all the studies confirm this idea, but based on this piece of evidence, we pose this third hypothesis. So we are going to represent these three hypotheses in this causal diagram, so you can figure out what are the three questions and the three hypotheses. The journal prestige and the institution reputation have a positive effect on post-retraction citations, but the misconduct severity, we assume that it has a negative effect in post-retraction citations. So I think it's time to talk about the data set we use, and now I will just define why we focus on these three areas. The data set comes from the Retraction Watch database. So very well-known database used in many situations, and we are very grateful to Ivan Oransky, who gave us the data set in May 2022. The database is huge. On that date, it comprised 27,000 items, 27,000 retracted articles. But we had to filter them to reduce the number of the database, because we were working with 200 undergraduate students. We didn't have funds, so it was an academic exercise working with 2 students, as I said at the beginning. So finally, we decided to focus on the area of business, social science, and technology. And then when we add other data necessary for testing the hypothesis I have mentioned before, the number of cases was 531. But the aim of this presentation, and the aim of this paper, is that for sure the area which is probably the most interesting one is medicine and health sciences. So we aim to suggest this methodology as a methodology that could be extended and applied to medical sciences. That could be very, very interesting. So the inclusion criteria, the cases that were included in the database were research and review articles from business, social sciences, and technology. Surprisingly, Retraction Watch has a category, which is BT, that comprises these three categories. And we believe that it was an appropriate area because our university, University in Madrid, covered the same discipline. So we are focusing in business, social sciences, and technology. So we believe it was a good idea to focus in this area. Then we check what of these articles has a DOI, because without the DOI, we cannot match the data. And finally, this is the reason we selected 531. Let me talk about the variables that we needed to add to this file, because Retraction Watch provides a lot of information, but we needed information about citations and other variables necessary for the model. These are the other data sources. So we search in Scopus for the number of citations from 2005 and 2022. The SNIP, which is a normalized journal prestige, and the site score indicators. We decided to use these two indicators to avoid any bias, so we decided to use two complementary indicators, and I will show you in the results the way we use these two indicators. From Semantic Scholars, we collected for each paper the highly influential citation, the background, methodology, and results, year by year, right? From the Center for World University Rankings, we collected the institutional prestige ranking for the highest institution in the paper. So, for example, if in a paper, one of the authors the affiliation was Harvard or Oxford, for example, and the other authors came from different institutions with a lower rank, we assigned the maximum rank to the publication, right? From Retraction Watch, we evaluated the Retraction Watch provides a very interesting information because they add to each paper the reasons the paper was retracted. So we use these reasons to apply the scale, the taxonomy that Hall and Martin published in 2019. They identified 4 categories of misconduct, from appropriate to blatant misconduct. So we rank all the publication we selected, 513 in 531 into this category. So each paper would have a score related to the misconduct severity, right? And when we built the database with all the elements, we were able to create these variables, right? The dependent variables are the variables that we want to explain post-retraction citations. And remember, there are the total number of citations, but also the different subtypes of citations, highly influential citations, background citations, method, and result. The independent variables, obviously, are the variables that we use for testing the hypothesis, the journal prestige, SNP, and site score. So we estimated models where we use SNP, and then we estimated the same model for site score. The institutional prestige, measured in the way I mentioned before, and the misconduct severity. And besides, you will understand in the next slide why, we need to consider the time, because each paper has its own story, right? So the paper is published in 1 year, retracted in another year, and we are in 2022, or actually 2025, but when we measured the data, we were 2022. But the time that goes from publication to retraction, and from retraction to today varies depending on the paper. So we need to consider this variable as well. And to control for heterogeneity, we also had to consider the citation before retraction, but not the number of citation. We had to normalize because the time issue I have mentioned, the different time, each paper has a different story. So in the next slide, I will explain you better what's the idea. So this is the paper. All the paper has a retraction date, and the time that goes from the publication date to the retraction date is relevant, because if we count the number of citations during this period, obviously it's going to be affected by the duration of this period. So we need to divide, to normalize this number of citations by the corresponding period. And this is what you see here. See before is the variable that is the ratio between the number of citations before retraction divided by its corresponding time before. And the same for the other type of citation. This is relevant because if we simply use number of citation, we will be estimating almost nothing. Probably we will obtain a result, but this is nothing, right? And the same happened after retraction. What I mean is that from the retraction date to 2022, the number of years depends on the paper. So in this case, we counted the number of citations, but we didn't divide by the time because the model is estimating number of citations. So that's why we need to find a type of estimation, which is called rate modeling. And this modeling is able to incorporate the time as an exposure variable. So we are able to enter the exposure for each of the papers without dividing by the number of years from retraction to 2022. So with this, keep in mind these technical issues, I will show you the descriptive of the sample. We can see that the main category was blood and misconduct, okay? So 47%. So it makes sense to take into account this study. Almost 50% of the sample correspond to cases where the misconduct was a serious misconduct. And now, after describing the data, I think it's important to focus on the methodology. I have avoided very technical details, but if you have any question, I will be pleased to answer you the question. So that regarding the methodology, first of all, we are estimating number of citations. So this is a count variable. So we need to use a model like Poisson or negative binomial. Poisson was discarded because of the over-dispersion. So we tested if there were over-dispersion. So we decided to negative binomial. Binomial is better. So we use the negative binomial, or because of the count nature of the variable, right? The rate modeling is what I mentioned before. The rate modeling requires that we have data that has been exposed to a cause or a factor for different time, for example. So we can encapsulate, we can incorporate into the model the time, not like the other variables, but a very special variable which is called the exposure, right? Which is here. So this is the place where we use the exposure variable, and it's very common in this kind of models. And for example, this is the model. X represent the variables, the journal prestige, institution, and misconduct severity. C is the categorical variable that considers the area, the research field, business, social science, and technology. It's a dummy variable, and Z is the control variable, the citation before divided by the number of years. So with these variables in the model, we figured out that by introducing this control, we are doing something which is very atypical in a model. We are putting information about what happened before retraction. And at the same time, we are putting in the same model information about what happened after retraction. And when we do that, we are removing a lot of endogeneity issues because we are comparing its case with its past. So we understood that this type of model removed many sources of heterogeneity, but besides, we decided to conduct endogeneity analysis by using instrumental variables and also the robustness analysis. I will show you later the result. Why? Because we felt that it was necessary, and as I will show you later the result, I think that makes sense. That makes sense, and we have incorporated this analysis. Okay, finally, we can see the results. This is the model for considering the SNP as the indicator of the journal quality, and each column corresponds to a type of citation, right? So this is for total citation, this is for highly influential citation, background, method, results, etc. And this is the SNP, which is the variable that measures the quality of the journal. So the first row is about misconduct, the severity of the misconduct. And as you can see, it's not relevant in any of the models. So it means that the hypothesis 3, at least with this data set, is not true. So we reject the hypothesis 3 because scientists apparently are unaware the severity of the misconduct, or they don't care. I don't know what this is, right? So the third one, the SNP, sorry, is the second one. And as you can see, is relevant, is significant for the total number of citations, and positive, of course, the highly influential citation and the background citation. So that means that the higher is the SNP, the more citation this paper received. Regarding the institution role, institution prestige, we also can observe, so this one is okay. Sorry. Okay. Regarding the institution, we can see that it's also relevant, but only for total citations and highly influential citations. And in the model, for sure, the most significant variable is the citations before retraction, because each paper has its own past. And if a paper has been cited a lot before retraction, will keep part of this inertia, right? So the number of citations will be even higher. So that's why these parameters are so significant, okay? But it's good because we are not ignoring this story. So we are measuring the effect of these other 3 additional variables besides the story, besides what happened before retraction. And also we can see that there is no effect, there are no differences among areas. For site score, we get similar results. For example, misconduct is not relevant as we have with SNP. Site score is relevant for total citations and background. None of them is relevant for method or results citations. And regarding institution, the institution prestige has also a positive effect but only in citations, total citations, and highly influential citations. The same pattern that we have seen before. So the previous citations for each paper are the main predictors of the future citations after retraction. And we confirm that there are no differences among these three areas. It could have been quite different if we had included, for example, medicine or biology or physics or whatever. So apparently the hypothesis 1 and hypothesis 2 are, we have tested that they are correct. The data fulfill these two hypotheses, but not the third one. Now let's conduct endogeneity analysis. So for the endogeneity analysis, we need a variable which is suspect to be endogenous. This is citation before. Citation before could be endogenous because citation after is related to citation before. So what we do is to select two instrumental variables, time before and number of authors, which are not related to post-retraction citations. And we use a method which is two-stage residual inclusion, which is a method that uses instrumental variables. And the key element of this method is that we consider, I'm going to highlight that we use this method for deciding whether the variable is variable citation before is endogenous or not. If we prove that the citation before that has been essential in the model that I have shown a few minutes ago, if we check that citation before is not endogenous, that's very good news for our model. And to check whether this variable is endogenous or not, we simply have to see if the coefficient to the residual citation before is significant or not. So this is the model with in instrumental variables and the SNP. So the difference with the previous one is that now we have the SNP and we have introduced the residual for the corresponding model, right? These are the variables that we don't want that be relevant, that we don't want that the coefficient would be significant. And as you can see, none of them are significant. So we are in the right way. Besides this model, which is not the model that we used for analyze the result, it's only an artifact that we use for checking that the previous one is correct. We can see that confirms somehow the hypothesis. So the journal practice is relevant, the institution is relevant as well, and the misconduct severity is not significant. So this is regarding the model with the SNP. Let's do the same with the citation score. This is the for citation score. We obtain also that citation score is significant here and here. The institution prestige is also relevant for total citation, but not for the different subtypes of citations. And the residual are not significant. So these are great news because in this methodology the significance of these parameters is crucial to decide whether the variable is endogenous or not. So overall means that the models that we have estimated don't have endogeneity issues. And taking into account this test, we didn't stop, and we decided to conduct a robustness analysis by using three different methodologies. First of all, multicollinearity, because a model can be free of endogeneity, but it could be affected by multicollinearity. We tested multicollinearity, and there is no evidence that the multicollinearity is present in the models. We made different specifications. So sometimes if we modify one of the variables, and this is what we did, we take one of the variables and we use the logarithmic transformation of these variables, we obtain the similar results. So obviously the value of the coefficients change, but the sign and the significance remained. So that also proved the robustness analysis. And then the third test that we conducted for testing the robustness analysis, so we are checking how strong our results we can extend or we can make inference by using this result, is splitting the sample into two pieces. So we split the sample by using the date, the traction date. On the one hand, paper retracted until 2015, and on the other after 2015. We ran the same models and we obtained similar result to the model with the full sample. And altogether, we say that these models are robust enough. So that's also very good news for our claiming. So this is the summary. And now, to conclude, I would like to share with you the key results regarding total citations. First of all, the prestigious journals and the top-ranked institutions, the journal and institution's prestige increased post-retraction citations, as also increased any type of citation, and the misconduct severity has no significant impact, actually has no impact. That could be interpreted like community isn't aware of the retraction, probably of the retraction as a whole, and of course they don't know the reasons. And pre-retraction citation is obviously the strongest predictor, so we have included the strongest predictor, and even taking into account that we have included a very strong predictor, we have been able to obtain significant parameters. And by citation type, we can see that highly influential and background citation are linked to journal and institutional prestige. Methods and results are not affected by prestige. I don't know how to interpret that, if it's good or bad, but I think that the most dangerous is that a paper considered highly influential, another paper which has been retracted. This is my point, but also results could be controversial. So you are using for supporting your results a paper that has been retracted. It also has serious implications. And misconduct severity has no significant impact. And that suggests altogether that there is a reputational inertia rather than a scientific merit drive citation, right? So this is essentially the paper. We also have added some implications and policy recommendation, but I think it could be interesting, the discussion of the question that you want to ask me. And particularly, I think that we can use artificial intelligence advantage for improving the whole process, because probably when a researcher including in the references list a paper that has been retracted is not intentional. So they are including the paper because they have used in other papers, so they have found that the paper, but they are not aware. And I think that we could use artificial intelligence. Journals can use artificial intelligence to post alerts when you upload a paper, for example, with a citing a paper that has been retracted. You should receive an alert or a pop-up window or whatever saying, "Be careful, this paper was retracted. You shouldn't cite it." Okay. So thank you very much for your attention, and I will be pleased to discuss with you whatever you want. Thank you.